Hey, Robotics and Automation, welcome back. Last week we started a VexCode VR assignment, and it was a real simple one, very basic. It took just a few seconds to put it together. But it was just you drive forward for 200 millimeters, and you drive back for 200 millimeters. Then you go forward for 400, you go back for 400, you go forward for 800, and you go back for 800. And millimeters, keeping this in mind for today, this will come important later. 200 millimeters is the same as 20 centimeters. 400 is the same as 40 centimeters. That'll come into play later on. But for now, let's just look and see what that did. It just went forward, back, forward, back, forward, and back. Now imagine if we slowed our robot down a little bit and we put a little bit of wait time in between so it would stop and then go. That's what we're going to do today with our actual real life with our Lego robots. Okay, so we're going to do this exact lab, but with our Lego robots, there's a few minor differences and a few things that you have to get set up before you can do it. So it's a little bit harder with the actual Lego robots, but it's also more fun because it's like in real life, so it's kind of cool. So now we're in here, we're just going to go to Prime. And we're going to go to New Project, just go to New Project right here with the plus. And you have to use word blocks, don't use Python or icon blocks. In this class, we'll just use the word blocks. And we'll create that. All right, so here we go. Now, the first thing that makes these a little bit interesting is before we get going and we actually tell it to move back and forth, you see, when you build this program, it's made to work with any Legos that are out there. And if you look here, these are just one type of wheel. But if you've ever looked up Lego wheels and how many different types, there's probably 100 or maybe 200 types of Lego wheels throughout all the decades. So Lego has to make this so it works with any kind of wheel. Okay, that's really important. They don't know which one you're going to put on, so we have to first tell it how big is the wheel so it knows if I go one rotation. A big wheel is going to go very far. If this wheel was very small, one rotation wouldn't move it very small at all. So the robot has to know how big is this wheel, okay? So what you're gonna do is we're gonna go to setup, and when program starts, we'll be there when you get going. Let me zoom in just a bit. So when program starts, that'll be going right there. And so what you're gonna do first is you're gonna go to, over here, there's a big list of all sorts of commands, and they're color-coded into groups. For example, if you can jump around to the different groups by clicking on the side. So if you want to control, go click control, and all those will all pop up. If you want to go back to movement, just click movement. We're going to start with movement, okay? So go to movement. We have to tell it how our robot's going to move. The first thing we're going to do is we're going to go down here, set one motor rotation, and then drag it out. And it's going to be set to 17.5. That is absolutely correct for these tires. If you had something different, we would have to change that. What that's telling us is if this thing spins around one full rotation, it's going to move 17.5, and that depends on the diameter or the circumference of the wheel. Both, actually, right? Or either one, I guess you could say. Okay, so then the next thing is, see these different chords? We could have chosen to plug them into A, B, C, D, E, F. It doesn't know where the motors are. The drive motors that's going to move it, we need to tell our robot, our program, exactly where that would need to be. So I'm going to drag out this one, set movement motors, and it says A and B, but our building instructions didn't say that. Our building instructions said to plug it into C and D. So you're going to click here, and you're going to move it on to C and D. All right? C and D. Finally, we're going to set the movement speed to 50%. These are all in the movement category. Now we've set up our robot and told it, here's where you find the motors. When you spin them, it's going to go a certain amount, 17.5. And hey, we don't want to go too fast because we're not in a race. We just want to make sure it's accurate and it doesn't slip, because going fast can do that. Let's just go to 50%, okay? So now we're ready to go. What we're going to do now is we want to wait. When we start the program, we set it down, and then we press this button to run it, and we give ourselves some time to move our finger out of the way. And then the robot will move back and forth like we want it to. So what we're going to do is we're going to go down here, and Go to events. Events is like when something happens. An event happened. Well, which one do we want? So we're going to go down, and it says when left button pressed. And we're going to drag that one out. Let me zoom in a bit. Now, when left button pressed, you could also change that to the right button. If you'd rather press the left or the right button, it doesn't really matter. You can use either one. And this is just pressed or released. Let's leave it on pressed. I guess it would be the same for us because we're just touching it and releasing it anyways. So then the next thing we're going to do is we want to give ourselves about a half a second of wait time to get our finger out of the way and for the robot to just kind of settle so it's accurate and it goes straight and everything goes good. You see, on the computer, everything works perfectly the way it should. But in real life with these Lego robots, if there's bad traction, it could slip, kind of like your parents if they peel out in their car a little bit, maybe hit the accelerator too hard on the gravel, they would skid out. And even though the tire moved, the vehicle doesn't move. We want to avoid all that stuff by just going with about 50% speed. And we want to give ourselves some time to get our finger out of the way and for the robot to stop completely, wait half a second, and then do the next part. So it's not moving around and shaking like a car that comes to abrupt stop. So what we're going to do is we're going to go down to control. That's the next one down. I mean, you could just go down, but I'm just going to click control. And the first one is wait. And so I'm going to put this here. This stuff just happens automatically when we run the program, but you wouldn't see anything happening because it's just information for the robot to know what's going on and how far it's going to go. This is the stuff that actually does stuff that we can see. Okay, so let's go back up to movement. And you guys, 1 second, you could do 1 second, but I feel like that takes too long. I'm just going to go delete that and put 0.5. Not to half a second. That should be plenty of time. If you want to go 1 second, go ahead, that's fine. Okay, and the top one says move forward for 10 rotations. We're going to change that, but let's drag it out and we click it in right here. See, this wouldn't do anything because it's not connected. You have to let go of them right here so they snap together. Okay, cool. We're going to move forward, and instead of 10 rotations, we're going to change this to centimeters. Now, earlier I was talking about what's the difference between a centimeter and a millimeter. Well, the difference is a factor of 10. Let me show you what I mean. So when it comes to centimeters and millimeters, so when we did this lab originally on the VixCode VR, we were using millimeters. And if I look, I only can select millimeters or inches. You can't even select centimeters on here, which is kind of weird because it's the exact opposite on the Lego program. When I look at Legos, I can select centimeters but not millimeters. So it's just the opposite. But the good news is they're really, really easy to convert. It's something you can do in your head, very simple. First of all, you have to know that millimeters are really tiny and centimeters are pretty significantly larger than that. So we know that it takes several millimeters to make 1 centimeter. Those are the smaller ones, okay? So just real quick, let's take a look. This is actually really easy. I'm making it harder than it is maybe. So if you have 100, let's say for example, somebody tells you move 135 millimeters. Here's how you do centimeters and change it into centimeters. It's 135, just like the other one. And then the decimal place here is actually after the 5. It's a hidden decimal point. So I'm just going to move it over, and then you just move the decimal place over 1, which is basically, this is exactly the same as dividing by 10. So 135 becomes 13.5 centimeters. Okay, now let's look at this. We have 200 millimeters, like we have to do for our first one. Let's keep it simple. Yeah, it's going to have a 2, a 0, and a 0, right? Since we don't see a decimal point, we know it's hiding at the end. So I move it over 1 place, which is dividing by 10. Oh, 20.0 centimeters. So for ours today, we're going to use, we have 400, so that becomes 40.0. We have 800, and 800 becomes 80.0. So our numbers today are going to be 20, 40, and 80. You could put 20.0, 40.0, and 80.0, but that's exactly the same number, right? It's like having $80 and no cents and $80. Those are the same thing, okay? All right, cool. So we got that. I got to use Paint to teach with. Good old trusty Microsoft Paint. So right here, instead of 200 millimeters, I'm going to change this to 20 centimeters and input that. Okay, now hold on. Before we go and do anything crazy, we should test our code and see if it works. So I'm going to plug that in and make sure that it gets connected. And it was successfully connected. You can tell your hub's connected when you can see these numbers on the motors. And what those are is just telling you how much the motor's turned. Look, as I rotate C, you can see the numbers changing. Go back the other way, it gets bigger. So you're connected and you're ready to download your program just as soon as you can see that. I'm going to move myself out of the way. And now what we're going to do is I'm going to press the play button. Notice how it's on program 0. I'm going to press play. Sorry, I got interrupted by the announcements. So I press the play button and this is ready to just disconnect. Okay, so now that we have downloaded our program to this, whoops, it's running. So basically what's going to happen is when you go to run your program, never ever run it when it shows the heart. Don't do it. That's not running your program ever, no matter what. Many people will do this until the end of the year. I don't know how else to explain it. If you press go when it's at the heart, your program will not run even though some of the motors might move. Instead, you're going to press the arrow key until you see your program, which is 0. That's our program, remember? And then we're going to press play. And then it's waiting for me to press the left button. So when I put it down on the floor, I'm going to press the left button. And let's see, it should go forward 200 millimeters or 20 centimeters, which is about the same as roughly 8 inches. Okay, and go. Oops. There it is. And hey, that's about right. That's about 8 inches. That's good. So let's go back and let's do the rest of our assignment on here and we'll try it out again. Okay, cool. So now we've got that. Oops. That one right there. Okay, so cool. We're going to plug our robot back in because you can't download your program again until you do that. And hey, look at that. If you wait a second, it automatically connected. I can see up here with the check mark that we are ready to go. Okay, now what we're going to do is we want to duplicate both of these together. So I'm going to right click on this one and duplicate it. So it's going to go wait half a second, move forward like you just saw. It's going to wait another half a second. We don't want to go right away because it would just back and forth. It would shake and it would vibrate and it would be inaccurate. So what I want to do is I'm going to wait half a second. Again, just right click and duplicate, put that down here. We're going to wait the half a second for it to stop moving and chill and take it easy. And then we're going to change it to reverse. So we just click on the arrow that's going backwards. Now if I did this right, it should go forward and then come back. Let's press play to download it. And you can also, if you don't want to download it, you can just click download to hub. There we go, and then it won't automatically play. It doesn't matter either way though. So I'm going to go over here. I'll switch my camera. And again, so we're on program 0. Press 1, press the middle button to run the program. And now remember, it's waiting for me to press the left button. Okay, so it went 20 forward and 20 back, about 8 inches each way. Okay, cool. Now you're going to finish up the project. The rest of it should take you just a couple of lines of code. See this? This is a chunk that moves forward and back for 20 centimeters and waits in between. We're going to duplicate this whole chunk. So you get another chunk like this, and I'm going to change both of those to 400 millimeters, which is 40 centimeters, like we talked about, right? And again, you can type in 40.0, it doesn't matter. Those are the same number, right? So it doesn't really matter. Okay, cool. And then I'm just going to go ahead and try the other one. Duplicate all that again. Make sure you get the weight. So you have weight, move. And I'm going to change these to 80 or 80.0, whichever one you want. Doesn't matter. Okay, and there I am. Hey, there we have it. And you look at that and we're ready to go. So I'm going to just simply plug it in and we should be done with our project. This is the last run. Plug her in. Hey, look at that. It's all ready to go. I can click this button to download it to the vehicle. and it's going to be running as program 0 again. Let's disconnect it, put it on the ground, and now we should have, I may have to actually zoom out a bit, move it like that. So now we should have a robot that's going to do all those moves back and forth. And run my program with 1, and then it's waiting for me to press the left or the right button. 200 millimeters, 40 centimeters, 40 back. And finally, the big one, 800 forward and 800 back, or 80 centimeters and 80 centimeters back. Okay, so as soon as you're done with this, your final job is to come and get me and just show me. I'm gonna say, hey, put it on the ground, show me. And I'll probably ask, I might ask to see your code as well on the screen when I do that. And that's how you get it done. So, hey, thanks everybody. And I'm really happy that we're gonna be working on these robots. We're gonna have a lot of fun with them. This is only the basic stuff, movement. Then the next thing we're gonna learn how to do is make it turn and all those things. So we're gonna build our skills throughout these different projects. Thanks everybody.